Hi, everyone, and welcome to another session of our Fresh Cut Flowers webinar. Hot greetings from Belgium. This day's topic is the cold chain, which is actually a good one because it's very relevant for a lot of countries in Europe at the moment. So, as you can see on your screen, there is a table with different topics. Today's is the cold chain. And the other topics are the following webinars, which we'll be doing, which is every last Thursday of the month. Take note of the ones you think are interesting and make sure that you can attend. Before I hand over to Emma Bradford, our technical support representative and your host, I just want to let you know that we will be recording the webinar and you will be able to find it on our YouTube channel if you want to replay it. And if you have any questions, please use the poll buttons, the question buttons on the sides, and send us your questions. And at the very end, Emma will take some time to try and answer all your questions. Enjoy. Take it away, Emma.
Thank you, Georgina. Hello, and welcome to the 6th webinar in our series. As Georgina just mentioned, my name is Emma Bradford, and today I will be talking to you about the cold chain. So, going over our roadmap of where I'll be taking you today, first, I'll explain what the cold chain is and why it's so important. I'll show you the optimal storage temperatures for your stems. What happens when your flowers get hot? I'll go over the different ways that flowers travel. And then lastly, I'll finish with some fun facts. So, you've probably heard about the cold chain, and most of you will know exactly what it is. But for those of you who don't know, and to clarify what I mean by the cold chain, this is what it is. So, in order to preserve as much VARS life as possible, it is very important that flowers are kept cold at each step of the supply chain. And by supply chain, I mean all of the points that are highlighted in blue on this graph. So from harvest to consumer, the flowers should be kept refrigerated at all times. The process of maintaining refrigeration from grower to consumer is what we call maintaining the cold chain. So why is maintaining the cold chain so important? Well, as I've mentioned in almost all of the previous webinars, temperature is the biggest factor which affects VARS life. And that's because it not only slows the flower's metabolism, but it also slows the development of botrytis and bacteria, and also reduces the sensitivity to ethylene and ethylene production. Now, all these benefits can only be gained while the flowers are stored at the correct temperature. So it's very important to keep your flowers at the correct temperature. So what is the correct temperature? Well, for most flowers, it will be between 1 and 3 degrees C and a relative humidity of 75 to 85%. But as with all rules, there are some exceptions, and this is for tropical flowers, which need to be stored at around 12 degrees C. So why exactly should flowers be kept cool? Well, although there are many benefits to keeping flowers cool, by far the biggest benefit is to reduce respiration and metabolism. Now, respiration in plants means a different thing to respiration in animals. It doesn't mean that the plant is taking in air. It means that the plant is converting sugar to energy. So you can loosely think of a plant's rate of respiration as its metabolism. So when we say that a plant's rate of respiration is high, we mean that its metabolism is high and it's burning sugar. A bit like us during a run. But unlike us, it isn't exercise that increases flowers' metabolism, it's warm temperatures. So when a flower gets warm, its rate of respiration, or metabolism, if you like, increases. This means that it begins turning its sugar reserves into energy. And just like us when we do run, when a flower's rate of respiration increases, the flower gets warmer. So the flower starts to produce its own heat too. Another harmful byproduct of respiration is reactive oxygen species, and this may promote flower aging and senescence. Now, senescence is just a sciencey way of saying that the flowers are dying. So, just to show you another way, as temperature increases, the rate of respiration, as the temperature increases, the rate of respiration increases. These two graphs show the rate of respiration when the temperature increases from 0 to 30 degrees for a rose and a gerbera. Now, you'll see that the line is curved and not linear, meaning it's not in a straight line. And that's because as the rate of respiration gets higher, the flowers begin to produce their own heat, just like we do when we run. So the curves are exponential. It means it gets hotter as the rate of respiration increases. Okay. So now we know that when a flower gets warm, their rate of respiration or metabolism increases, and they also produce heat. What does that mean for VARS life? Well, in a nutshell, it means that the VARS life will be shortened. Think of it this way. Storing in a flower in a chiller at 1 to 3 degrees versus storing it at 16 degrees C is like the difference between slowly walking or running fastly for us. So if you walk slowly, you will get further over time than if you run really fast, simply because you will use your energy more slowly and consistently instead of in a short, quick burst. And these two graphs show just that. You can see that in the graph on the left, as temperature increased from 2.5 degrees to 15 degrees, the rate of respiration increased exponentially. And in the graph on the right, you can see that as the VARS life in days decreased from 9 to about 3 as the respiration rate increased. And then lastly, just to hammer it home, you can see how the VARS life of the Antirrhinum and gerbera were affected by the temperature in which they were stored. So Antirrhinum and gerbera, which were stored at 0 to 13 degrees C, you can see how the VARS life was prolonged at the lower temperatures than just a few degrees warmer. Just to recap all of that, when you store stems at 1 to 3 degrees, its metabolism and other biological processes are slowed down. In warm temperatures, respiration produces energy the flowers use, but it also produces heat and reactive oxygen species. So flowers should only be in ambient temperatures at the consumer's home. So far, so easy, right? Well, there is one big challenge to maintaining the cold chain, and that's the fact that the flowers have to travel. Now, that's mostly due to the fact that the bulk of the flowers are grown in the world are not close to the areas where they're consumed. So, depending on where they are grown, flowers will either be air freighted or sea freighted, but at some point they will always be transported by road. Now, it's all very well to know that that happens, but this is what it actually looks like in real life. Now, obviously, some methods of transportation are easier to maintain the cold chain in than others, but I'm going to focus on the two which travel the furthest, and that's air freight and sea freight. Now, the benefit of air freight is a relative speed of delivery. So shipments can usually be sent from grower to recipient in about 12 to 24 hours. But on the other hand, it can be expensive, and the volume you can ship is restricted. And lastly, the cold chain is rarely maintained, unfortunately. So the good thing about air freight is that flowers aren't in transit in less than ideal conditions for very long. With sea freight, on the other hand, it's much slower, and travel times can be a minimum of 2 to 3 weeks, minimum. But the cold chain maintenance is ideal, and volume is not an issue, plus it is much cheaper. So just to show you what kind of temperature abuse can occur with air freight, you can see on the graph on the left how much the temperature fluctuated between about 9 degrees C and 21 degrees C in the space of about 4.5 days. And the temperature in this case was recorded every 12 hours. And you can see in the pictures on the right just how much that temperature increased of the flowers. So as the rate of respiration increases, the flowers actually get warmer as well. Now, sea freight, on the other hand, is much easier to maintain the cool chain in. And that's because each container has its own refrigeration unit, and the flowers can be kept at the correct storage temperature from the time the container is filled to the time that it's emptied. Now, in the graph, you can see how the temperature of the data logger from just before loading to 3 weeks later. So this was a period of time from the 30th of July 2013 to the 24th of August 2013. Now, as you can see, during the time it was in the container, the temperature was consistently between about 0.5 degree to 2 degrees. So no more of a fluctuation of 1.5 degrees more or less. So even though sea freight is ideal for maintaining the cool chain, there are some key things that you must do if you're using sea freight. Now, because it takes so long, there are some really essential steps you must take to ensure that good flowers go into the container and good flowers come out. Firstly, select the correct crop and cultivars within that crop. So there are some crops, like chrysanthemums, our Alstroemeria, which can be stored dry for long periods with minimal negative effects, which are perfect for sea freight. But within those crops, you will also find varieties which ship better than others. Next, treating your stems prior to shipping is a must, as they need to be correctly prepared for the long journey ahead of them. So that means treating them with a good hydration solution, such as Life Hydroflor 100, and protecting them from botrytis and ethylene damage by using your Life transport paper and Ethyl Block. Next, ensure that your temperature controls on your container are set correctly and that everything is in working order. And then lastly, you must ensure that the stems are rehydrated on arrival, and you can use either the Life Express 100 hydrating solution or the Express 200 transit solution. Now, there is one more consideration for sea freight, and that's the type of box that you use and how they are loaded into the container. So for the cool air to circulate correctly within the container, the boxes require the presence of air vents, and for those air vents to be aligned with each other to allow the cold air to circulate from one box to another. There shouldn't be any gaps between the boxes to ensure maximum correct airflow. So to summarize all of that, always store your flowers at the correct temperature and relative humidity. Limit the amount of time that the flowers are stored out of the cool chain and avoid temperature fluctuations. A warm flower is a respiring flower and will also produce heat. And if you're using sea freight, always choose the best suited crops and cultivars and ensure that the container is in good working order and that it's loaded correctly. Now, carrying on from that, I have a couple of shipping fun facts. So, did you know that the largest container ship is named the OOCL Hong Kong? And it is capable of carrying 21,413 containers in total. That's a picture of it right there. It's huge. Another fun shipping fact is that about 33% of all cargo vessels have absolutely no means of communicating with the outside world, and only 10% of them have internet access at all. And then my last shipping fun fact, and I'll get back to flowers. In 1 year, a cargo ship will travel the equivalent of 75% of the distance to the moon and back. That's in a year. That's amazing. And then a couple of fun facts about growing areas. So in 2017, Kenya exported 160,000 tons of flowers, and that made up 38% of all the cut flower imports coming into the EU. Now, Colombia is just as important, and Colombia has 8,000 hectares that have been turned over to the cultivation of flowers in total. So that's our webinar for this month. Does anybody have any questions?
Thank you, Emma. Yep, we did get a question during your presentation, and this one's from Jeff, and he asks, does Ethyl Block have a lifespan? Will it last for the whole transportation time in sea freight, or should I add a couple of extra sachets?
Good question, good question. So, I love explaining Ethyl Block. So Ethyl Block is a gas. It's a gas treatment, and the active ingredient in it is the 1-MCP. So 1-MCP, how it actually works to protect the flowers from ethylene is that the 1-MCP molecule mimics the shape of the ethylene molecule. And what it does when it gets inside the plant is that 1-MCP molecule will actually dock to ethylene receptors within the plant, but it won't elicit the negative ethylene response that ethylene does. So what Ethyl Block does, and the 1-MCP, is it will get inside the plant and it will effectively take up all of those ethylene receptors. So think of it like a car park. And you've put cones. So the 1-MCP is a cone. You've put cones in all the car parking spaces. So when a car comes along, there's no more spaces for them to park in. And that's the same thing that happens with the ethylene. The 1-MCP docks with all the ethylene receptors so that when ethylene does come along, there's no free receptors for it to dock to, so you can't elicit the negative response. Now, you know that anything that the ethylene receptors that are treated will only be the ethylene receptors that are present at the time of treatment. So what could happen is that as the plant develops or opens a little bit more, or the stems open, new receptors can be available. They can grow and can be available. And those ones will not have a 1-MCP molecule in them. They'll be free for the ethylene to dock to. So what we say is the most important time for you to protect your flowers is during the transit time. And you have a good 2 weeks of protection before new ethylene receptors start becoming available, basically. So what I would do in the case of a shipment that is going to be longer than 2 weeks is treat them again at the end for 4 hours before they get sent out, just to top up that protection. Adding more at the beginning won't extend that time. You'll have to retreat them again at the end of the 2 weeks.
Okay. Yeah. Thank you for the very clear explanation. That was it for questions on the presentation. We do have a question regarding the videos. Yep, so we're recording all the webinars and then we'll upload them to our YouTube channel. We're running a little behind with the order. I think there's 3 online at the moment. The following 3 we will upload hopefully next week. I will make sure that everybody gets an email with the different links in it so you can rewatch or download the recordings. Oh, wait, we have one more question from Craig. You spoke about keeping flowers at 1 to 3 degrees Celsius range and the effects of too much heat. What happens if the temperature drops below 1 to 3 degrees Celsius? Can some plants handle that?
Yeah, that is also a good question. So what happens in that case is that you will actually risk getting chill damage. So anything below sort of 0.5 degree, really, you risk the cells. So if you imagine if you live in a temperate climate in the wintertime when we get a frost, very often that will actually damage the plants. And why that is that your cells in your plant do contain water. And as we know, when water freezes, it expands. And what happens is the water inside those cells, if it freezes, the water will expand and it will burst through the cells, and that will cause chill damage, basically. So yes, we don't want them to get too cold. There is such a thing as too cold for flowers, definitely.
Uh-huh. Okay, that's good to know. Let me see. That was it for our questions. Emma, thank you for your time. For our attendees, thank you for joining, and we hope to see you next month.
Thank you.
Bye.
Bye-bye.